Hello and welcome to the last module of this course, which is all about software performance. Software performance is sort of something that we've discussed, in the previous modules. So in this module, what we're going to be talking about specifically is, first of all, the underlying concepts that affect performance, so as far as hardware is concerned. And second, we're going to add the missing pieces of the puzzle, if you want. So all of the other things that affect performance that haven't been mentioned so far in the previous modules. So let's look at what's in the core of SketchUp as far as the hardware is concerned. So really open up the machine and look at the guts that make it, if you will. All of the parts that I'll list here will be classified in decreasing order of importance. So from the most important part to the least important part in making SketchUp run, and therefore also in making the program performant. So the first part is for the CPU or the processor. So the CPU is involved in all modeling operations. It is responsible for displaying faces and edges of a model. So that means that every single time you make an edge or a face in your viewport, the processor needs to calculate the vertices positions of this face or edge and needs to feed them back to the video card so it can display them afterwards. One thing to note here is that even with a multi-core system, SketchUp will still only run on a single core. So the best processor for SketchUp is a processor with a high single thread performance, so high performance on a single core. Having a very performant multi-core system is still useful though, because a lot of the rendering plugins that SketchUp has do use multiple cores. The next most important part as far as hardware is concerned is the GPU or the video card. So the GPU is involved in displaying shading, textures, shadow, fog, and advanced style effects. So basically anything that's not a basic edge and a basic face in your model will be displayed by your video card. In fact, even basic faces and edges also need to be processed and displayed by your video card, but that's easy. So when we talked about styles, that's why we sort of said that, you have to be careful with the amount when you start adding additional things that SketchUp needs to display in real time, such as shading, textures, shadow, fog, because this all piles up on the stuff that your video card needs to process. That's why it's important to keep those things minimized when you're just modeling. Also, one important thing to note is that some rendering plugins also use it partially to render the models in conjunction with the CPU. Alright, so the next part involved is RAM, so random access memory, and HD type, so hard disk type. RAM is involved in all operations. More RAM increases the maximum file size of the model you're able to work with. So basically, when you open a model inside of SketchUp, SketchUp stores as much of that model as possible in your RAM. And what it means is that if you have more RAM, your loading times are going to be decreased and your action times on heavy models is going to be decreased inside of SketchUp. However, if you're working with a heavy model, having a lot of RAM won't make the actual modeling faster because you'll be able to open it quickly. But if the model is heavy, it means that it has a lot of edges, so the CPU is still going to be the bottleneck in your pipeline and the overall modeling speed will still be quite slow. The other point is that an SSD or a solid state drive will load models significantly faster than a regular hard disk. So compared to the two other factors, RAM is minor. The reason I'm mentioning it is because, especially in the later stages of the modeling process, your model is going to become heavy, so loading times will become important, and you'll be exporting your model to layout, and layout needs to fetch your SketchUp model from time to time to update the views inside of layout, and therefore you're going to have a lot more loading operations inside of layout than you do inside of SketchUp. So if we were to summarize what most often is the bottleneck, you could basically say that it's always between the CPU and the GPU depending on your system. Basically, if your system has a very powerful CPU but has a less powerful GPU, then most likely the GPU is going to be the bottleneck. If your system has a powerful GPU but doesn't have powerful CPU, the CPU is going to be the bottleneck. However, if you go a bit more in depth in the specific types of performance issues that you can expect, we can identify usual suspects more clearly, and they're not always hardware related. So if you're having issues with viewport fluidity, so the ability to move and work freely inside your model without experiencing lag or crashes, Then your usual suspects are, yes, indeed, hardware related most of the time, so CPU and GPU. If you're experiencing problems with software stability, on the other hand, so random crashes or crashes when you access a specific function inside of SketchUp, then the usual suspects are either the CPU or your extensions. So extensions have the tendency to crash the software when you click on them, and either there's a bug in the code of the extension itself, or you haven't done one of the prerequisites that the extension requires before you take a certain action. So that causes random crashes. And if you're experiencing problems with loading times, so slow loading or crashing when you try to load or import a file or send a file to layout, the usual suspects are also random, but mostly RAM and extensions. So not enough RAM would tend to cause your model to crash in these situations. And also, once again, extensions. If you're trying to load a file, especially a SketchUp file that has been modeled with certain extensions, sometimes these extensions will leave remnants of code inside of the model that will make your software crash. Similarly, if you're trying to export a model into layout that has been altered by some extensions, it might cause layout to crash. Especially this applies to rendering extensions. That's why I always keep my rendering extensions turned off until I am ready to use them, because I've had a few files crash when I tried to import them into layout because I was using a rendering extension. Now here, for all of these categories, there is one thing that's really important to keep in mind, and that thing is that you can drastically increase performance and software stability with proper modeling discipline. So the solutions to the performance issues that you saw in the previous slide, aside of course from upgrading your hardware, which is always a good thing, are for viewport fluidity, is to use an appropriate style for modeling. So don't overload your video card with displaying, extra textures, extra shadows when you don't really need them, and get used to swapping components between, workable and presentation models. For software stability, the workflow solution is to organize your extensions in sets and only use them when they are required. For loading crashes and slow loading times, it's really important to convert groups into components, because components will decrease your file size and therefore make it easier to load. And purge unused geometry, which we will go over in this module. So in this course, you've seen most of the solutions that are written here. We're only missing a few pieces of the puzzle. So in the next clip, which is going to be our demo section, we're going to go over these missing pieces and complete the picture.